So, very good morning to everyone, and today we are going to see about an asynchronous session on node voltage analysis. So, node analysis is basically it's based upon the KCL law, and in this particular lecture, we are going to know about how to solve the circuit using nodal analysis and how to find the nodal voltages for different complex networks. So node voltage analysis finds the unknown voltage drop around the circuit between two different nodes or between different nodes that provide a common connection for two or more circuit components. So as the name implies, the node voltage analysis uses the nodal equation of the Kirchhoff's first law to find the voltage potential around the circuits. The Kirchhoff's first law is nothing but your Kirchhoff's current law. So by adding together all these nodal voltages, the net result will be equal to 0. Then if there are n nodes in the circuit, there will be a n minus 1 independent nodal equations, and these alone are sufficient to describe and hence to solve the circuit. So at each node point, write down the Kirchhoff's first law equation. The current entering a node are exactly equal in value to the current leaving a node. Then express each current in terms of voltage across the branch. For n node, one node will be used as a reference node and all the other voltage will be referenced or measured with respect to this common node. So this is the basics node voltage equation circuit which has a single node, and we can describe a VB as a single node. So in the circuit node D, for example, if you see over here, the node D as a reference node, and the other three nodes are assumed to be have the voltages of VA, so VA and VB and VC with respect to node D. For example, while writing the equation, you'll be getting a VA minus VB by 10, VA minus VB by 10, VA minus VB divided by this is resistance, plus VC minus VB divided by 20 is equal to VB divided by 40. So as VA is equal to 10 voltage and VC is equal to 20 voltage, and also you must be remembering a things. So this is 2 plus 2 minus. So the current is flowing from minus to plus, and here also the current flowing from minus to plus. So there is a potential drop is happening with respect to this particular node. So we are writing in terms of minus 10. So by solving the equation VA with respect to 10 voltage and VC is equal to 20 voltage, we will be getting a 1 minus VB by 10 plus 1 minus VB by 20 is equal to VB by 40. So 2 is equal, while solving this equation, we will be getting around VB is equal to 80 by 7 voltage. So that is the voltage at this particular node. So in order to have a current over I3, that is I3, we need to find out the what is the current VB minus 0 divided by 40. So VB is already we know that 80 by 7 minus 0, that is a reference node, and we will be getting a divided by 40 ohm. So while solving these things, you will be getting around the I3 will be around 0.286 ampere. So this is the simplistic nodal equation we formed by using the simple circuit. And generally, the node voltage analysis is more appropriate when there are a large number of current sources around, around it. The network is then defined as I is equal to Y into V, where I are the driving current sources and V are the nodal voltages to be found, and Y is the admittance matrix of the network which operates on V to give I. The summary of a nodal voltage analysis is write down the current vectors Assuming the current into a node are positive, that is the n into 1 matrices for n independent nodes. So how many nodes are being there? We need to write that much amount of a nodal equation. So write down the admittance matrix of the network where y11 is equal to, that is y11 is equal to the total admittance of the first node, and y22 is total admittance of the second node, and rjk is equal to total admittance of joining node j to node k. For net network with n independent node, the y will be n into n matrix and ynn will be positive and yjk will be negative or zero value. The voltage vector will be n into L and will list n values to be found. So that's all about the nodal voltage analysis, and we'll be solving a few problems based upon the nodal voltage analysis in the next asynchronous video. Thank you all.